Hi everybody. So we're just going to do a little bit of a short video today and how you like my lanyard, my alligator clip lanyard for my microphone. Uh, hey, necessity is the mother of invention. So I thought I would talk to you today about fuses because, well, I had a very interesting experience and wanted to share it with you. Pretty funny, cool story. But what led up to this was I am currently working on my next project, which is the Phase Linear 400. And the speaker fuses happen to be these. These are called AGX fuses. And when I went to remove the fuse out of the cap, so you can see the cap is right here, it was stuffed way up in there. And when I went to pull it out, this happened. It just came right out because I'm like a bull in a china shop. Well, not necessarily a bull in a china shop. Maybe I'm more like Sasquatch in a china shop, except less hair. Well, unless you count the top of my head, but you get the point. So I figured, well, I'll just get another 8 amp fuse. But as you can see, there's a little problem here. There's my 2 fuses. This is your standard AGC type fuse. It's just, what is it? 1¼ inch, I think they call it. And I forget how many millimeterage. I'll put it on the screen. But this is a type AGX fuse. In their infinite wisdom, Phase Linear decided to use this type of uncommon fuse for the speaker fuses instead of the very common AGC fuse. There's really no reason for that, because if you look at the fuse holder in this, it's the same length and everything. It takes up the same space as a standard AGC fuse holder. So you even need a special fuse holder for that. As I drop the thing on the floor, and now it's gone. Okay, so the parts eating floor strikes again. But anyway, so this is a 1-inch long fuse instead of a 1¼ inch. That's the difference. Same diameter. But that's not really what this is about. The only AGX fuses I had in stock were 2 amp, not 8 amp, because these are very uncommon, but there was an old X-ray machine that used these and had some of these left over from it. And if you take a look, this AGX2, meaning 2 amp, it's a 2 amp fuse. But if you look, it has a couple things on there. IR 100 amp 250 volts and 10 kiloamps at 125 volts. What's that all mean? And so basically, this is a 250 volt maximum fuse. Yes, fuses have voltage ratings. Everybody's like, it doesn't matter the volts you have. Everything, it's the amps. Well, yeah, the fuse will fail at that amperage, but it is also dependent upon voltage. There's things called breaking current and maximum breaking voltage that you have to think about. Now, what brings this all about? Well, when I went to order the 8 amp version of these, I noticed that they had a 250 volt version, but they also listed a 32 volt version. Same fuse, both AGX2s or AGX8s, but they had 32 volt and 250 volt. And you'll see this quite often, because even with these ones, the old automotive fuses that were AGC like this, they look just like this fuse, and they probably have a different thing other than AGC, but people will generically call this an AGC fuse. But the ones used in the automotive industry back in the day were 32 volt rated fuses. All the other ones that you see in appliances and things like that are 250 volt. What does that mean? Well, the maximum breaking voltage of a fuse is the maximum voltage where when the fuse opens, it will open the circuit in the allotted time that's specified in its spec sheet. So what that means is fuses don't you can't just put a time on how long it takes a fuse to blow, because it really depends on a bunch of things. It depends on the ambient temperature of the fuse at the time. It depends on how much you're exceeding the maximum current of the fuse. So this is an 8 amp fuse. And if I run it right at 8 amps, it'll run for a really, really long time. But this will actually get hot to the touch. This is like a little resistor in there. It has resistance. So there is a voltage drop across this filament of this fuse. And as it heats up, once it gets to a hot enough temperature that the metal softens to the point where it'll rupture and open, that's when it breaks the circuit. But then you go from a very low impedance circuit in here to a very high impedance circuit, and you're doing it all at once. As soon as that filament breaks open, whatever potential was at the circuit now is across this fuse, because it's open circuit. It's high impedance now, very high DC resistance, right? Everybody gets mad when I say impedance, and they're, you mean DC resistance? Okay, I'll say DC resistance. So when that happens, you get a little arc flash as this thing opens up. That arc flash creates plasma inside here. It will continue conducting through that plasma for a set period, for a certain period of time, until finally that it extinguishes the rest of the way. Now, this is the simplest form of fuse, just a glass fuse with a filament in it. But some of them are ceramic, because they take higher heat, and they're filled with sand. Some of them actually have a semiconductive element in them instead of just a filament, but we're not going to get into all that today. The bottom line is that voltage is very important. If you try to put a 32 volt rated fuse into a circuit that's running on mains voltage, which is either 120 or 240 volts, when that fuse has to open at that rated current, what's going to happen is as it opens, it's not going to extinguish, because the reason it's rated at 32 volts is that that's the maximum voltage you should have across there on an open circuit here to guarantee that it will rupture in milliseconds. If you put a higher voltage than that, it'll still blow. The fuse will blow, but it will maintain conducting for a period of time, and it can be many milliseconds sometimes before it will finally burn up inside the little cartridge here. And that little bit of time might be just enough to take out the circuitry. Okay, you can cause a lot of problems with that. So I've noticed that I'm really hitting the volume here on the microphone. I'll turn this down a couple clicks. There we go. Probably distorting. So anyway, long story short, make sure that the maximum voltage exceeds the voltage that the circuit that's going to be in the open circuit when that fuse blows open. Okay, so in other words, if you're protecting a mains voltage circuit, make sure you have a 250 volt fuse, not a 32 volt fuse. Now, what are these numbers here? These IR, 100 amp and what's it say, 10,000 or 10 kiloamps. That is your breaking current. So what the heck's that? So that is a rating of how much current it can withstand when you overload the fuse. So for instance, in this one, if I have a 250 volts, so I'm running at mains voltage over, for instance, in Europe or something where they use 240 volt mains, and I get a really, really nasty short where your feed lines are very, very thick gauge wire, everything's set up to draw incredible current, you can actually have it draw 100 amps through this very shortly before it ruptures the fuse. And it'll still be able to break that fuse very rapidly. But if you have a circuit that will exceed 100 amps, the same thing's going to happen to this as if you exceed its maximum voltage. It's going to take longer for it to blow. Now, if you have a lower voltage across there, like this, 125 volts, then it can actually break up to 10,000 amps. It's a huge difference just by cutting the maximum voltage in half. So for those of you who may ask, what the heck's the point in having a 32 volt fuse when you could just stick a 250 volt one in there for everything, as long as the amp rating is the same? That's why. The 32 volt fuses have very high breaking current as opposed to the higher voltage ones, and that's why. They have a different way that they will fail than the 250 volt ones. Now, why am I telling you all this? Well, it's because when I went to order these fuses, I noticed that there were the 32 volt and the 250 volt versions. This amp has about 80 volts on it, so it will exceed, if a transistor dead shorts on this, all of that voltage from your power supply is going to go out your speaker terminals, because this does not have a speaker protect in it. And it is going to very quickly fry your Sherwin Vegas, you know what I mean? So you want the correct fuse that will fail in the correct manner. 32 volt fuse is not good enough. You have to make sure you put a 250 volt fuse in there. So I ordered the correct one. Now, what's the story? Well, I was at work. It was a couple months ago. I was at work and I got called in on a 80 kilowatt X-ray generator. It was a pretty high powered device. And it had failed catastrophically, to the point where there was fire extinguisher powder all over the inside of the power cabinet because it caught fire. The people in the building panicked. The maintenance came up. They didn't know how the equipment worked. They didn't know what they were doing. They just started spraying it like a cat in heat. Well, you can imagine what a mess that made. Now, this health system does have an in-house group, meaning they have repairmen that work on X-ray equipment, can do the preliminary service on it, and kind of minimize the cost of calling people like me in. And they had spent weeks trying to rebuild all this, and they couldn't do it. So I got called in, came in meticulously. We go through and we get this thing rebuilt. We got it down to, there was a bad fuse. It was a 25 amp fuse, and it was rated at 700 volts. And the power supply that it was protecting, or the circuit that it was protecting the power supply from, whatever you want to say, that power supply produced 650 volts at a lot of amps. We'll just put it that way. Many, many amps. And that fuse was blown, and we had replaced all the circuitry inside this big power unit, had all the bad juju out of it, we thought. And so the only thing left was this fuse. Now, these fuses are hard to get. They're about 40 bucks a piece, plus shipping. The end caps on them, they're really big. They're ceramic. They're a semiconductive type fuse. I won't get into what those are. Even the end caps were silver plated for better conductance, or better conductivity. And we didn't have any. I ran out of them. I don't carry a whole lot of those. I do have some stuff in stock, but I have to order it. Well, he wanted the in-house guy wanted to test this thing before we went home for the night. And he said, I'll go down to HVAC, to the maintenance department, and I'll go into their HVAC department and see if they have a fuse for, one of the HVAC units that's similar. So he comes up with a 30 amp fuse. 25, 30, at that rate, it's not going to make a huge difference for temporary, but that's okay. But when I looked at it, it was one of those cardboard tube fuses, and it was only rated for 250 volts. And remember, this is a 650 volt circuit. And I went through the schmeal that I did with you guys just now about this. And he's like, well, it shouldn't matter, we're just testing it. And I'm like, okay, we'll use it. If your call, you want to use it, we'll use it. Stuck that fuse in there. I was the lucky one standing in front of the cabinet when we turned it on. And I'll tell you what, the ball of fire that came out of the front of that thing when that fuse went was unbelievable. It was about that big around, and it blew traces off the back of a board. It made an ear shattering, I mean, sounded like my 12 gauge shotgun going off. And so much of this stuff, neither one of us flinched. We just looked at one another, and he said, well, I guess we didn't get all the shorts out of it yet, did we? And I said, no. And I said, there is a very good example of when you have the wrong fuse. Because when that thing blew, it made that loud explosion, because once that filament vaporized inside that fuse cartridge, it turned to plasma, and it kept conducting until you had fire. It did eventually break the circuit, but only after more circuitry was damaged. Turns out that there was a wire that went from that fuse, you know, from that circuit, and it went out of the cabinet. It went to a different rack, completely different area, and there was a MOSFET, big power MOSFET, a couple of them that were dead shorted on that circuit. And since it was in a different location and it wasn't causing us any problems, we never caught that problem. And had we put the correct fuse in, we'd have been out $40 plus shipping. But chances are it wouldn't have taken out additional things. That fuse would have probably opened very, very rapidly, and we'd have just said, well, fuse blew, there must be something else wrong. So the lesson learned on that is make sure you use the correct voltage of fuse when you're replacing these, because those are the kinds of things that can happen. It's important. And you know, when you go to the auto parts store, or you go to your local hardware store or whatever, a lot of times they will mingle in those 32 volt type fuses like this along with the 250 volt. Be aware of that, okay? So that's all I want to tell you, an interesting, funny story. And the next video you're going to see is a whole series on this and a Model 700 and an associated the phase linear preamp. It's going to be a wonderful series. It's going to be pretty involved, but these are pretty good examples. We'll go over some of it, and yeah, I have a high tension cable here. That's another thing. This is a high voltage cable, in case you've never seen one, and these are what the high voltage going to an X-ray tube goes through. So here's the center conductor. You see that red colored rubber? That's the insulation layer. There's 3 wires, and they're kind of silver plated wires. They're very good conducting wires. This is very flexible. And the outer jacket, there's some Teflon tape around it, and then there's shielded braiding on that. You can kind of see it down in there, and it's shielded all the way, and it's connected to this collar. So this is all connected to ground. And the center conductor is where your high voltage is, and there can be up to 75 to 80,000 volts on these wires in the middle. And they go through these federal standard connectors, and they come out these 3 pins. And the reason there's 3 pins is because an X-ray tube has 2 filaments in it. Unlike a normal vacuum tube, it has 2 filaments. So you have a smaller sized filament, a larger sized filament, and guess what? They're called the small filament and the large filament. And then there's a common. They're both connected to the common. And that's what these 3 pins are. This plugs down into the X-ray tube housing, and this provides 1/2 of the power for the tube, because there's 2 of these. One on the anode side and one on the cathode side. On the cathode side, these 3 pins go to the filaments and also are to the cathode connection. On the anode side, you use the same cable, but inside the X-ray tube housing, these 3 pins are all tied together. So they're shorted together. And what I'm doing is we all carry one of these in our cars, so that you can, if you're testing a tube filament, you can just pull the candlestick, as we call them, out of the tube, plug this into the cathode, and then we kind of strip these wires out, and you can hook your meter to them, and you can check the filaments to see if you have an open filament or shorted filament to the cathode cup or something like that. It's a really good test tool made out of an old cable that you ripped out of an old machine. So I'm going to make up one of those for one of the employees. Actually, I'll probably give him one of mine and keep this one. Doesn't matter. But that's what that is. So anyway, till next time, I wish you all peace, joy, happiness, and good health in your lives. And make sure you get the right fuses, because you never know the kind of damage you can do if you don't. Take care. Bye-bye.